Hi, I'm Troy McClure. You've seen me in a number of chemistry educational videos, such as Chapter 9, Stoichiometry, and Chapter 12, Solutions. Now today we're going to be looking at Chapter 16. We've jumped the number of chapters because this is such an important topic. Our last chapter we looked at was Chapter 12, Solutions. You got to learn about concentration. That's going to be totally applying to what we're going to cover in this chapter here. But today, our objective for this one, guys, we're going to understand about how do you describe acids and bases? What is it that they do exactly? You're going to be able to understand the classification of substances as acids or bases according to the Bronsted-Lowry idea, because there is more than one. But Bronsted-Lowry covers a lot of different types of acids and bases out there. So, observable properties of acids. Where do we even get the word acid from? It comes from the Latin acidus, which means a sour taste. Now, if you've tasted lemon juice, not lemonade, but lemon juice, you notice it has a sour taste. Another thing that acids can do, they provide electrolytes. Now, you may have been hearing this in Gatorade commercials. But what are electrolytes exactly? Well, it's a substance that ionizes. Ionizing, remember, it breaks apart into a positive and a negative, okay? And it conducts electricity within a solution. So if I had a glass of pure water there, and I stuck two wires in there hooked up to a battery and a light bulb, if it's pure water, I'm not going to get a lot of results in there because water is not that great of a conductor of electricity. But if I add some vinegar in there, because vinegar is an acid, okay, you're going to watch that light bulb light up. And the more vinegar you add in there, the more the light bulb's going to light up. Amazing. Now, acids also react with active metals to produce hydrogen gas and a salt. Now, when we talk about salt, we're not talking necessarily NaCl. That's one kind because we can get sodium hydroxide and hydrochloric acid, combine that together, and we can walk away with water and salt. Salt is a big umbrella word. It covers different things. It's a metal with a non-metal in there. Okay, so we know that acids will react with active metals, and they make hydrogen gas and a salt. Now, hydrogen gas is also flammable. Okay. Now, if we look at bases, it's a little bit easier to get through. And you might have noticed I put in pictures. You may notice I put pictures here. And you can see, wow, there's a lot of things here that are considered acidic. Exactly. Now, when you look at the next page, you kind of notice, ooh, wow, look at all these everyday items you can actually find in the kitchen or in the bathroom at home. Are they bases? Yes, they are. Now, they tend to be bitter to the taste. Okay, now we're talking about straight up, it's the base. It's not, you don't add anything to it. Now it does feel slippery to the touch. How come? That's because your skin is being broken up by the base, okay? Your organic skin cells are being torn apart. That's what bases do. And if you look at Drano there, that's a drain opener. Oh my gosh, what that does to hair. No, this is not the result of base, okay? Now, some of the bases out there are in fact electrolytes. So there are some that they will conduct electricity a little bit, but not all of them. Acids are way more common. Have you ever heard of a battery base? No, you've heard of a battery acid. And there you go. Let's keep on moving. Now, acids and bases, they're opposites of each other, okay? And I'm reminded of an old song by Paula Abdul back in the 1980s. It says, when opposites attract. And when we talk about an acid and a base, we can talk about that they will cancel each other out. If you have an equal amount of acid and an equal amount of base, when they combine, they're going to cancel each other out, and that's a neutralization reaction. Ultimately, what it produces is salt and water. Or I should say, a salt and water, because salt is not just sodium chloride. There are others, like if we look here in this neutralization reaction, Acid plus base equals water plus salt. So HCl and NaOH is water and NaCl. But we have nitric acid, HNO3, and potassium hydroxide. You get water and potassium nitrate. That's a kind of salt. The potassium is the metal, the nitrate, the NO3, is a non-metal. So that's another kind of salt. I personally wouldn't put it in the mouth. I'm just saying. Now we got to talk a little about these guys here, Bronsted-Lowry. They really have a very simple definition of acids and bases. There are others. There is you may remember Lewis from the Lewis dot structure. He has his own definition of acids and bases, okay? There is another definition. I'm not going to worry about that. I'm going to focus on this one because this covers most of the acids and bases out there. This is a quick, handy one. Now, Bronsted-Lowry acid donates a proton, a hydrogen plus. You'd say, but wait a minute, you got an H plus. Now, am I remembering off the periodic chart, that's hydrogen, right? And that plus means it lost an electron, right? Yep. But why do you call it a proton at that point? That's because the hydrogen plus is a single proton. Remember, hydrogen is made up of one proton. It could be one proton, one neutron, and one electron, or one proton, two neutrons, and one electron. That would be a heavier form of hydrogen called tritium, or it's just simply a proton with an electron. So when an acid, a Bronsted-Lowry acid, gives a hydrogen plus, that tells us it's an acid when it gives it away. Now, on the other hand, a base is the opposite. If the acid's giving away that hydrogen atom, that lone proton, the base will accept it, and that's what makes it a base. And actually, these are the two guys here, Bronsted and Lowry. Lowry was actually a pastor. You know, go figure. The guy had an interest in chemistry. Okay, so deprotonation and protonation. So deprotonation, you're losing a proton, which is what acids do. They deprotonate. Okay, protonation, on the other hand, they're picking up a proton, which that is what you get in a base. Yep. So, with that, ladies and gentlemen, okay. So, quick check. So acids and bases are opposites of each other. How come? Well, acids, what is it that acids do? According to Bronsted-Lowry, they give a proton. Now, what's a proton? Hydrogen atom with a plus. And the base, a Bronsted-Lowry base, takes in that proton. It's a proton acceptor. That proton being an H and a plus. Well, hey, I'm going to stop that one here for you. This is a quick introduction to the differences between acids and bases. I hope this clears it up because there's lots of examples of acids and bases in your everyday life. You just weren't aware of it. For many of you, you probably weren't aware of it. And you know what? That's okay. That's why you're in school. Or should I say, you got schooled? Ah! All right, I'm going to stop here.